Enterprise security teams are currently struggling with a critical remediation bottleneck where the average mean time to repair a critical vulnerability sits at roughly 60 to 100 days, while modern threat actors often develop functional exploits within 48 hours of a public disclosure. The fundamental challenge in modern vulnerability management is no longer the discovery of flaws, but rather the massive volume of noise generated by automated scanners that frequently overwhelm human analysts with thousands of low-context alerts every week. Traditional Common Vulnerability Scoring Systems, or CVSS, provide a generic severity rating but often fail to account for the specific environmental context of an asset, such as whether a vulnerable service is actually exposed to the public internet or shielded by internal network controls. Artificial intelligence is now being integrated into the Security Operations Center to provide context-aware risk scoring by dynamically analyzing network topology, active traffic patterns, and real-time exploitability data to determine which vulnerabilities pose a genuine threat. By utilizing large language models specifically trained on historical exploit code, security advisories, and internal documentation, security teams can automate the initial triage phase that previously required hours of manual cross-referencing and research. Advanced AI agents can correlate disparate data points from endpoint detection logs, cloud configuration files, and network telemetry to perform reachability analysis, which confirms if a specific vulnerable code path is actually accessible to an external attacker. This focus on reachability allows organizations to deprioritize up to 70% of their vulnerability backlog, effectively filtering out theoretical risks and focusing engineering resources on the small fraction of exposures that represent immediate business risk. Automated remediation goes beyond simple alerting by leveraging AI to generate ready-to-merge pull requests that include the necessary library updates, dependency adjustments, or configuration changes required to close a security hole without breaking the build. When an AI detects an outdated or vulnerable package, it can automatically perform a compatibility check across the entire codebase, suggesting the specific semantic version upgrade that provides the necessary fix while maintaining existing functional requirements. The integration of AI into CI and CD pipelines ensures that security becomes a proactive gate, where automated vulnerability analysis occurs at the moment of code submission rather than being discovered weeks later during a scheduled production scan. However, moving toward autonomous remediation requires a high degree of trust in the AI's ability to interpret complex security documentation, making the implementation of retrieval-augmented generation or RAG essential to prevent the model from hallucinating non-existent fixes. Modern security frameworks utilize RAG to ensure the AI only references verified and authoritative security databases, such as the National Vulnerability Database or vendor-specific advisories, before suggesting a remediation step to the engineering team. Implementing a loopback mechanism is a critical architectural requirement, allowing for a human-in-the-loop oversight process where the AI proposes a complex patch and a senior security engineer can review, validate, and approve it with a single action. This hybrid approach significantly lowers the barrier to entry for junior analysts by providing them with AI-generated explanations of why a vulnerability matters and how to fix it, effectively upskilling the workforce while maintaining high standards of oversight. One significant advantage of AI-driven security tools is their ability to perform patch twinning, where a proposed fix is automatically deployed and tested in a virtual sandbox environment that mirrors the exact configuration of the production server to detect regressions. This automated testing process identifies potential performance degradations or service interruptions before the patch ever touches a live production environment, mitigating the fear that security updates will lead to accidental system downtime. In addition to software patching, AI is proving invaluable in remediating cloud infrastructure misconfigurations, such as overly permissive identity and access management roles that provide services with significantly more access than they actually require to function. The AI can analyze the actual permissions utilized by a service over a 30-day window and automatically generate a least privilege policy that eliminates unused access rights, thereby shrinking the potential lateral movement surface for an attacker. For legacy systems that cannot be easily updated due to vendor constraints, AI can suggest temporary compensatory controls such as specific web application firewall rules designed to block the exact patterns used by known exploit payloads. This concept of virtual patching buys the engineering team critical time to refactor underlying code or negotiate vendor updates without leaving the organization exposed to active exploitation during the intervening weeks or months. The shift toward AI-enhanced security operations fundamentally changes the role of the security analyst from a manual researcher and ticket filler to a strategic orchestrator who designs and monitors automated remediation workflows. To be successful in this new landscape, IT professionals must understand the underlying mechanics of how large language models interpret technical documentation and how to validate the outputs produced by these generative systems during a crisis. Enterprise training becomes essential because misconfigured AI tools can lead to a false sense of security or even introduce new configuration errors if the prompts used to generate the fixes do not account for enterprise-specific security policies. Data privacy is another major consideration for L&D buyers, as organizations must ensure that proprietary source code sent to an AI for vulnerability analysis is handled within a secure, private environment that complies with data sovereignty laws. Leading enterprises are now deploying private, fine-tuned instances of AI models within their own virtual private clouds to maintain total control over their data while reaping the productivity benefits of high-speed security automation. The result of these advancements is a more resilient and elastic infrastructure that can adapt to the evolving threat landscape in minutes rather than months, fundamentally shifting the strategic advantage back into the hands of the defenders. Industry metrics show that organizations using AI-integrated security workflows see a 40% reduction in the total cost of data breaches, primarily due to the significant acceleration in detection, containment, and final remediation times. Furthermore, the burnout rates among security operations center analysts are significantly decreasing as the most mundane and repetitive aspects of the job are offloaded to intelligent agents capable of 24/7 monitoring and triage. Enterprise L&D leaders should prioritize programs that cover both the theoretical aspects of AI model training and the practical application of these tools within the specific context of a modern, multi-cloud enterprise security stack. The ability to write effective, technically accurate prompts for security analysis is quickly becoming as important a skill for the modern engineer as the ability to write automation scripts in Python or manage infrastructure with Terraform. As we look toward the future of cybersecurity, the gap between organizations that successfully leverage AI for security and those that rely on traditional manual processes will continue to widen exponentially, creating a new tier of digital risk. Securing the modern enterprise requires a complete reimagining of the entire vulnerability lifecycle, moving away from static spreadsheets and toward dynamic, AI-powered remediation streams that operate at the speed of the cloud. This involves deep cross-functional collaboration between DevOps, security, and IT operations teams to build unified workflows that prioritize speed, accuracy, and system stability across all stages of the software development lifecycle. By adopting these advanced AI-assisted techniques today, companies can build a sustainable and scalable security posture that protects their intellectual property without requiring a proportional increase in headcount or annual security spend. Ultimately, the goal is to create a self-healing infrastructure where security is an inherent, automated property of the system rather than a bolted-on afterthought that hinders innovation and delays the delivery of critical business applications. If you are ready to master these cutting-edge techniques and transform your security operations, explore our cybersecurity AI training at ProgNXT to learn how to lead the next generation of intelligent, automated defense strategies.